Okay, we are on to the final question of this set series. And this question says that the use of electric vehicles will curb air pollution in the long run. So we are getting a lot of electric vehicles nowadays. Their use is increasing day by day to minimize the air pollution, and the use of electric vehicles is increasing every year. And estimated vehicles in use at any time is given by the function V. So if we put where T is 1, 2, and 3, and T corresponds to the year 2001. So that means if you put 1 in this equation, that will give us the number of vehicles in that particular year. So if you put 1, that will give you the number of vehicles in 2001. If you put 2, that will give you the number of vehicles in 2002, and 3 for 2002. So this is the equation 1 by 5 t cube minus 5 by 2 t squared plus 25 t minus. So based on our information, answer the following questions. Can the above function be used to estimate number of vehicles in the year 2000? So for t is 1 for 2001, and for 2000 t should be 0. So let's try to put 0 here, and let's see if it gives us the number of vehicles. If it's the positive, so that means it's valid. If it's negative, it's not. So 1 by 5 into 0 cube minus 5 by 2 into 0 plus 25 into 0 minus 2. So these all terms are 0, which is negative 2. And vehicles cannot be negative. So number of vehicles cannot be negative. So in a particular time, the number of vehicles cannot be negative, so given function cannot be used to find number of vehicles in a town. Okay, now we have to prove that this is an increasing function. Increasing function means that its first order derivative should be greater than 0. So let's try to differentiate this. So our function is Vt is equal to 1 by 5 t cube minus 5 by 2 t square plus 0.5 t minus 2. So differentiating this with respect to t gives us this is 3 t square by 5 minus this is 5 t plus 25. And we have to show that this is greater than 0, and for that let's try to get this in the form of, let's take 5 LCM. So this is 3t square minus 25t, and 5 into 25 is 125. And if I take 3 common here, so this is 3 by 5, which gives me t square minus 25 by 3 t plus 125 by 3. And this can be written as 3 by 5. And if we use completing the square, let me just try to get it in the form a minus b the whole square. So this is minus 25 by 3 into half, which is minus 50 by 6. So t square minus 25 by t by 3 plus 125 by 3. Let me add. So we don't have to take the negative sign, just multiply the coefficient of t with half. It is 25 by 6. So 25, this should be 25 by 6. 25 by 6. So I'm going to add and subtract the square of 25 by 6. So this gives me 3 by 5, and this is now t square. So this, and this makes up t a minus b the whole square plus 125 by 3 minus this is 25 square is 625 upon 36. So if I try to solve this, this is 3 by 5 into t minus 25 by 6 the whole square. So LCM of 3 and 36 is 3. This is 12. 125 into 12 is 10. 5, 2 into 1, 2, 5. So 10, 5. This is 1500 minus 625. And this is 3 by 5 and t minus 25 by 6 the whole square plus 1500 minus 6 to 5 is 5, 7 and 8. So this is 875 by 3. Now this is positive. 3 by 5 is obviously positive. Square is positive. T minus 25 by 6 the whole square is positive. So 875 by 3, 36. This is 36. It's also greater than 0. So that means this is greater than 0. So because the first order derivative is greater than 0, so that means this function is increasing function. And this was this set of the series. Okay, so we have proved that the VD is an increasing function by proving that the first order derivative is greater than 0. So do like, share, and subscribe. Thank you for watching.